Hello everyone! It's another learning episode. I hope you are excited and very willing to learn in every video lessons I have for you. Again, this is your teacher, Marlene Nuno, and we are going to see the wonders of geometry in today's topic about the similarities of figures. Are you ready? But before that, our topic is indicated in the most essential learning competency number 36, which is to illustrate similarity of figures. Now in today's time, most of us becomes plantitos and plantitas. It is very relaxing watching and caring different plants. These are some of my collections, where I can say my stress reliever, as others say too. Now, can you spot their similarities? Yes, the three plants on top are of the same shape, while the plants below are heart-shaped. These are the real-life application of geometry. Let us see the details. Here are similar polygons. These are the common figures in geometry. In geometry, polygons are similar if they are of the same shape but not necessarily of the same size. So which colors in the figures are of the same shape? Yes, the trapezoids, which are yellow and violet, the triangles, which are red and white, and the rectangles, which are colors blue and pink. Now to formally describe similar polygons, let us see the following examples. Similar polygons are those that have congruent corresponding angles and proportional corresponding sides. Let us look at these figures. Observe the trapezoid ABCD is bigger than the trapezoid EFGH, but trapezoid ABCD is similar to trapezoid EFGH. Let us see why we told this so. Let us see in details how we can say that the figures are similar. So first, we have to look for the congruent angles. So looking for the congruency in symbols, we can say that angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G, and angle D is congruent to angle H. Now, after checking the congruency of the corresponding angles, we will now check the proportionality of their corresponding sides. So, we have to show that AB is to EF is equal to BC is to FG, and that must be equal to DC is to HG, and AD is to EF. So substituting the length of the sides, we have AB is equal to 6 and EF is equal to 3. Then BC is equal to 10 and FG is equal to 5. Same with DC, which is 12, and HG is 6. And AD is equal to 8 and EH is 4. So if all of this ratio is simplified, the result is 2 to 1. There is 1 and common scale factor. And this is 2 is to 1 as the scale factor. That is our way of checking the proportionality of the sides. Now let us have another figure. let us see how to prove these similar triangles. So in the figure are two different size triangles, where triangle ABC is similar to triangle XYZ. Looking for their corresponding congruent angles, angle A is congruent to angle X because their measure are both 50 degrees. Angle B is congruent to angle Y. They are both right angles. And angle C is congruent to angle Z because the measure is both 40 degrees. Now we have to check for the proportionality of the sides, such that AB is to XY is equal to AC is to XZ is equal to BC is to YZ. Now substituting their angles, AB is 6 and XY is 3 centimeters, while AC is 10 and XZ is 5 centimeters. Then BC is 8 and YZ is 4 centimeters. Then simplifying its ratio will result to 2:1. So the sides are proportional. For the next examples, our task is to find the missing parts of the similar figures. So given, triangle ABC is similar to triangle DEF. We have to find X and Y. Now since the triangles are said to be similar, as stated in the given, and the given are focused on their sides. So we have to look for the proportional sides, such that AB is to DE is equal to AC is to DF and is equal to BC to EF. So substituting the given, we have AB is 3, DE is X, where AC is 5, DF is Y, same with BC which is 4, and EF is equal to 8. So similar to our past videos, in solving proportion, we have to look for the ratio where there is a complete. So we have to use 3 is to X is equal to 4 is to 8 to find the value of X. By cross multiplication, we have 4 times X is equal to 3 times 8. Simplified to 4x is equal to 24. Then dividing both sides by 4 so that x is equal to 6. Now to find for y, we have to use the ratio and proportion. We have 5 is to y is equal to 4 is to 8. Then again, by cross multiplication, we will get 4 times y is equal to 5 times 8. Where 5 times 8 is equal to 40. Again, divide both sides by 4 so that the value of y is 10. Now to check for the proportionality, let us proceed to our original proportion and substitute the obtained value. So we will arrive at 3 to 6. Is it equal to 5 to 10? Is it equal to 4 to 8? And if we have to simplify the three ratios, the result is 1/2. So the sides are proportional. Now let me show you this problem. The sides of a triangle are 8, 16, and 20. The shortest side of a similar triangle is 10. How long are the other sides? So to easily solve the problem, it is important this to illustrate. So let us draw the first triangle and let us label this. The shortest side is 8, the longer side is 16, and the longest is 20. Now in the next triangle, the shortest side is 10. So if you're going to look, our original is 8, meaning it is a larger triangle. So let us label the shortest side of the similar triangle as 10, the longer side as M, and the longest as N. Now, we have to look for the proportional sides. So let us have the proportions 8:10 is equal to 16 is to M is equal to 20 is to N. So these are the corresponding sides. Now to solve for M, let us use this proportion. 8:10 is equal to 16 is to M. By cross multiplication, we will get 8 times M is equal to 10 times 16, where 10 times 16 is 160. By dividing both sides by 8, we will get M is 20. The same process to find for N. Let us use the proportion 8:10 is equal to 20 is to N. By cross multiplication, we have 8 times N is equal to 10 times 20. And 10 times 20 is 200. And dividing both sides by 8, we will get N is 25. Now let us check if the values we obtained are correct. Let us substitute in our proportion. 8:10 is equal to 16 is to 20 is equal to 20 is to 25. By simplifying this, 8:10, by dividing both the numerator and the denominator by 2, we will obtain 4:5. The same thing with 16:20, the similar number or the LCM is 4. So we will obtain 4:5. And the same process with 20:25, where the LCM is 5. So 4:5 is what we call the scale factor. So our obtained values for M, which is 20, and N is 25, are correct. Well, that's all I can share. If you have some questions or clarifications or request topic to discuss, let me know by writing your comment below. And please keep on watching my YouTube channel, Teacher Marlene Nuno, and do subscribe and hit the notification bell for the updates of my video lessons. Now, it's time for me to check how well do you know. So what are the two important properties of similar figures? So try to answer this. Write your answer in the comment box so that you have the chance for the raffle. Thank you for watching. God bless everyone.